So my plan for today is I went through like a document on this PDF here. I'm not sure if you guys can see my document, but let me go back and share my desktop. Okay, so in the last class, I've done like kind of a very quick review on how to find reactions and bending moment and shear diagrams for very simple structure. I have a couple of topics, and then we head to the SAFI training. So the first topic for today is called statically determinate and indeterminate structure, and I will let you know what does this mean. But guys, by now you know that for a structure to stay in place, it has to meet and satisfy three conditions. Sigma forces in the x direction equal to 0, sigma forces in the y direction equal to 0, and sigma moment around any point equal to 0. We call those three equations equilibrium equations. We can write those equations for the entire structure, so that's something we can do. And we can also write three equations for every individual part of the structure. So if we're able to split my structure into different pieces, then I can write for every individual piece, because still every piece is in a static equilibrium position. So I can write three different equations. Now, guys, the discussion coming is, you will see it's kind of a pure mathematical discussion. Okay, pure mathematical discussion, but let's pave the way to that. So let me ask you, when we have one kind of reaction, sorry, a roller support, okay? If I have a roller support, how many reactions do I expect? Looks like it's one. You can see it's my document here. It is in fact uh, one reaction, okay? And so if you have a hinge support, then we get two reactions. And if we have a fixed support, we get three reactions, okay? So guys, let me show you. Look at this picture here. When you look at this picture here, it's kind of a cantilever from one side, another cantilever from the right side, and in between there is kind of a beam which is connected through hinges to the cantilever from every side. So let's think about this problem and let's see how many reactions do we have. So when you look at this problem here, you will see for sure on the left side here, we have a fixed support. So then we get 3 on this side. So we get 3 on this side, and on this side we also get 3. And so now, so far, we have 6 unknowns. We have 6 unknown because, as I said, support reactions are initially unknowns. And in our way to find the bending moment and the shear, then we need to find the reactions. So far in this simple structure, we have total of 6 unknown reactions. And then what happened is, when you think also about the intermediate hinges, which is this hinge and this hinge, you will see every hinge will create 2 extra unknowns. Those are the internal forces inside your hinge, which means, guys, in this picture here, we have total of 3 plus 3 plus 2 plus 2. So this, guys, will give us, in this system of structure, we have total of 10 unknowns, 10. Now, let me ask you mathematically, I'm not sure, like, what's going on my my PDF here. Let me disconnect myself and then connect myself again, and let's go to this guy here. I don't know what's going on. Okay, anyway, I cannot use the shortcut, but I'm saying here, guys, so we have so far, we have 10, we have 10 unknowns. Okay, now let's go back to the mathematics. Okay, in mathematics, if I give you equation x plus y equal to 5, x plus y equal to 5, are you guys able to find the value of x and y? My question is simple. If I give you a single equation, and I say x plus y equal to 5, are you guys able to find the value of x and the value of y? Or there could be many values of x and many values of y, they satisfy this condition? Any help?
Many values.
Thank you, Hamid. Yeah, you're right. There are so many values. So guys, probably you learn sometimes in your math classes that the number of equation must equal the number of unknowns. The number of equation must equal to the number of unknown. And if those numbers are different, we run into mathematical problem. As I said, if you have one equation, x plus y equal to 5, remember we have two variables or two unknowns, and this is a single equation. It means my system of mathematical equation cannot be solved. I need more equations because I need to balance the number of equations and the number of unknowns. So guys, you can see the discussion right now is not structure, it's simply math. But this mathematical concept which will lead us to the structure soon. One more time, in order for my system of equation to be solvable, so we can find the values of the parameters or unknowns, then the number of equation must equal the number of equations. Okay, now let's go back to this problem here. So as we said, every support will give a number of unknowns or reactions depending on the type of the support. So we have 3 on this side here, we have 3, and so also we have on the other side, we have another 3 reactions. And then every intermediate hinge will create 2 extra unknowns or 2 extra intermediate forces inside your hinge. And that's why our total unknowns for the system is simply 10. So guys, look at this. If I have 10 unknowns, to be able to solve the system mathematically, I need 10 equations. But the question is, where can I get my equations? My equation simply comes from the equilibrium of this system. And as we said, every piece or every part of the structure, it is able to generate for us 3 different equations. So now I'm going to ask you a question, and then please try to help me. If I ask you, in this system here, how many parts? How many parts do I have in this system here? Do I have one piece or one part, or I have 2, or I have 3? How many?
3.
Thank you so much, Jelly. So really it's 3. We have from the support on the left to the hinge, that's one piece, because we have a hinge, so we can split our structure at the hinge. And then we have another piece in the middle. We have another piece on the right. Now, because we have 3 parts, and every part will give us 3 equations. So now how many equations in total I can write for this structure? I'm going to say it one more time. So we agree a minute ago that this structure has 3 different parts. And every part, we are able to write 3 equilibrium equations. So my question is, how many equations total I can write for this entire structure?
3.
It should be 10 too, because for the entire one, 3.
9.
For the entire 3.
So I'm saying for every part of the structure, I can write 3 equations, sigma x, sigma y, sigma moment. So those are 3 equations. I can write the 3 equations for every part, and I have 3 parts. So how many equations in total I can write?
9.
Yeah, 9.
Thank you so much. That's correct. So we can write total of 9 equilibrium equation in this structure. Now I want you guys to remember, so I have available 9 equations. However, I have total of 10 unknowns. Please tell me, and please forget about the structure for now, mathematically. If we have 10 unknowns and we have 9 equations, can we solve this thing mathematically?
No.
Yes, the answer is correct. Yes, you're correct. No, we can't. And that's why we call this is unsolvable. And simply in structure, we call it indeterminate. We call this system indeterminate because simply the meaning of indeterminate, it means the equilibrium equations, they are not sufficient to solve the system of unknowns. Okay, so guys, this is very simple concept, and what you have to do to solve any and to know whether your structure is determinate or indeterminate by comparing two numbers. If the number of equations is the same as the number of unknowns, then we're great. It's called determinate, solvable. We can find all the reactions from the equilibrium equations. However, if the number of unknowns exceeds more than the equation that we can write from the equilibrium, then in this case, we call it indeterminate structure. Okay? So what you see right now, the picture you see right now, 100%, it is indeterminate. It's indeterminate because we have 10 unknowns and we have 9 equations. Why 9? Because we have 3 parts, and every part it can write 3 equations. So 3 times 3, then that's 9. And then why do I have 10 unknowns? Because I have 2 fixed support and 2 intermediate hinge. So 3 plus 2 plus 2 plus 3. So you get total of 10. What I'm saying right now, by the way, is written on the document. We have total of 10 unknowns and we have 9 equations. And that's why, what do we call this system? We call this system statically indeterminate, because the equilibrium equations are not sufficient to solve for the unknown, which is the reaction. Now, if both of them are equal, so for example, if I have a simple beam and the simple beam has a hinge and roller, so when you have hinge and roller, in this case, you have total of 3 and it's an individual piece. So we can write 3 equations. So we have 3 unknowns and 3 equations, which mean my system is solvable. And we call this one statically determinate. Let me introduce for you another name, which is very important. And this name, it's called redundancy or degree of indeterminacy. Okay, so guys, now we know that there are 2 different numbers we can estimate. So here I have letter R. Do you see this letter R? So the R here represents the number of unknowns. Very simple. Identify the support type, and you guys know roller 1, hinge 2, fixed 3. If you have any intermediate hinge, the intermediate hinge will add up 2 more unknowns. So this is how you estimate the R. Now for the 3n, simply n is the number of parts in your structure, because every part will create 3. So the total of equations is going to be 3n. If the balance, it means the difference is equal to 0, it means it is determinate. If the R is more than 3n, then the difference equal degree of indeterminacy or degree of freedom. Okay, so which means if we apply this concept on this structure here, it means my degree of indeterminacy is equal to 1, because I have 10 unknowns, I have 9 equations, so I'm deficient by 1 equation. I need 1 more equation to be able to solve this system of structure. So guys, this gives you an idea of the meaning of determinacy and indeterminacy. Now, I'm sorry, I don't know what's happening to my system, so please bear me. Probably in the break, I'll have to fix this one, okay? But here is an example for us. We have four guys. We have 4 different structures here. We already solved one. So this one on the top right here, it has been solved, and we know the redundant, it is indeterminate. Number 1, it's indeterminate. Number 2, it is first degree, it's 1 degree of indeterminacy. Okay, and then I'm gonna also guide you on how to solve number 2, number 3, number 4. Please watch, huh? Please watch. Okay, now I'm gonna ask you, but I need some help. I need you guys to interact with me, please. Okay, so now I'm gonna look and try to solve and see this beam here. It's a simple beam that has an overhang to the right. Let me ask you, can you please identify the type of the support? For example, is it fixed? Is it hinged? Is it roller? So guys, please, in a second, unmute yourself and tell me this support here where I'm pointing out right now. This support here, is it hinged, roller, or fixed?
Hinge.
Thank you. Thank you. One is enough. Okay? Because it's hinged. How many reactions I'm going to get on this side?
2.
Thank you. How about this one?
Roller.
1.
Roller. Thank you. Roller 1.
Roller.
And then we get one reaction. So guys, look at this. So we have 2 reactions here and then 1 here. It means I have total of 3 unknowns. Remember, I don't have any intermediate hinge, which means no hinges here. Now, I'm going to ask you a question. How many pieces in this structure? Is it 1, 2, 3, 4, 5? Any help?
1.
Thank you so much. It is 1. And please don't say that this is a simple beam and this is a cantilever. It is 2 pieces. Actually, you can see the beam is continuous, which means this is 1 piece. And if it's 1 piece, anyway, how many equations can we write? So n here, n is equal to 1. And if you multiply 1 times 3, because every component or every part can write 3 equations. So here we go. Okay, here we go. We have 3 unknowns, and then we have 3 equations. So this means we call this system statically determined. Statically determined. Okay, now let's move on to the one on the bottom left. Okay, the one on the bottom left. Exercise is very simple. Number 1, one more time. Identify the type of the support. To the left, it is fixed. And then we have 2 more rollers, which means I'm going to say it and hopefully you guys agree. We have total of 5 unknowns. 5 unknowns, if you agree. 5, because we have 3 from the fixed. We have 1 from the roller, another roller. So that's 5. Now, a question for you. Please answer and then quickly mute your mic. How many pieces the structure is?
1.
Thank you so much. Yes, it's 1. It's not 2. Okay, it's 1 continuous piece of structure, which means because we have 1 piece, it means 1 times 3, then we get 3 equations. Now let me ask you, because we have 5 unknowns, and we have only 3 equations, does it make it statically determinate or indeterminate?
Indeterminate.
Thank you so much. Is it true? It's indeterminate. Now let me ask you, what is the degree of indeterminacy? How many, what's the deficiency?
2.
How many equations
2.
do we need more? Exactly
2.
2. So we go ahead and say 5 minus 3. So this will give you 2. And so it's 2 degree indeterminate, 2 degrees indeterminate. It means I'm deficient by 2 equations. Guys, finally, let's do the last one, which is the top left picture. Now, let's do the exercise one more time. Identify the type of the support. On the bottom left, we have fixed support. And remember, please count. So that's 3. And on the top right, we have you can see it's not roller, it's a hinge, which means we add another 2. So total of 5. And also in the middle here, where I'm pointing right now, simply we have another 2. So we have total of 7. 7 unknowns. 3 for fixed, 2 for hinged, and 2 for intermediate hinge. Okay? So we have total of 7. Now, let me ask you, and please unmute yourself and speak out. How many pieces in this structure?
2.
2.
Thank you so much. True, it's 2, because we have a hinge here. So we can split those into 2 pieces, because we have 2 pieces. And every piece can write 3 equations. So how many equations available for me? Equilibrium equations. Very simple.
6.
2 times 3, so you get 6. And what does it mean? Remember, my unknowns, they were 7, which means I am deficient because I have so many unknowns more than the equations. It means I'm deficient by 1, which means this is statically indeterminate and the degree of freedom is 1. Okay, I want to say something before I move on. You can see here the answer is here. If you go down in my document, you will see the answer is here. Okay, and then I'm going to move on to another topic, which is called stable versus unstable, which is another interesting structural topic. I'll cover this one soon, but I have kind of a side comment before I move on. Guys, now you can see structurally determined, we can do that manually. You know, like if I give any one of you a simple beam, you can do that because simple beams are statically determined. We write equation of equilibrium and then we solve the equation together. We can simply find reactions and then shear and then bending moment. How about statically indeterminate? Statically indeterminate, those are deficient. It means we don't have enough equations to find out. I'm gonna reformulate, sorry, I'm gonna reformulate my statement. We don't have enough equilibrium equation. We don't have enough equilibrium equation to mathematically find the unknown. Okay? So at the end of the day, you guys know that it's not a magic. If we have one equation and we have two unknowns, there is nothing, there is no way of finding the two unknowns unless we are able to find another equation that we can balance our system and make it solvable. Would you agree or disagree? Hello.
Agree.
Thank you. Okay. One more time. If I have one equation and two unknowns, there is no magic. You cannot find the X or Y. You need to find another equation to balance your system, and then you can solve for the unknowns. How this is being done in a statically indeterminate, we find other equations, but not equilibrium, not sigma x equal to 0, not sigma y equal to 0, not sigma moment equal to 0. However, there are some other equation, for example, for deflection, we can find other equation, and this will make our system solvable, and we can find the reactions. Okay. Now, one closing comment for this part is statically determined structure can be easily solved manually. However, statically indeterminate structure, it is kind of hard to do it manually, and that's why the preference will be to a software. The software can create as many equations as you wish. They can solve how many equations, even 1,000 equations. And again, if you want to remember from your math background, okay, let me tell you. Guys, did you ever learn in your math classes anything about matrix? I'm not
Yeah.
sure. To be honest, that's
Yeah,
question for you. Matrix.
we did
Okay.
algebra.
Yeah. Okay. So guys,
God.
did you learn how to make an inverse for a matrix? Inverse.
Yeah.
Okay. How easy to make an inverse for a 2x2 matrix?
Very easy.
Very easy. How easy to make an inverse for 3x3 matrix?
Very difficult.
Thank you so much. That's all I want to hear, by the way. That's all I want to hear. You can see
Is there any marks for this answer?
Excuse me?
Is there any
It
marks
needs
for this
marks.
answer?
For sure, I gave you that. I gave you. What's your name?
Ayushman.
Okay. 1 mark for you. Okay. Again, as I said, guys, listen. Again, marks don't come from my salary. I swear, if it comes from my salary, I will never give you a single mark. Okay. So
But are you
anyway,
gonna
yeah,
count these
contribute to the
marks?
class and you will get a mark. I bet you.
But are you gonna count these marks, or they're just for our motivation?
No, you will see when you solve your assignment. If you get 99% and you're missing 1 mark, I'll give it to you from your credit. You have a credit. You have a credit of 1 mark right now.
Sir,
Okay.
it's not supposed to be in the assignment. It's supposed to be in the exam, in the quiz. You have to add
That's
that.
Right
that's too
on.
much. Sorry, that's too much. Okay, I'm generous, but not that generous. Okay. Anyway, that was fun. As I said, guys, solving the structure like in terms of math manually, it is going to be very time consuming. However, the software simply can do the calculation way faster than us, and that's why any indeterminate structure we prefer to do it using a software, which we will learn today. So today in our class, you will learn a lot about structural software. Okay. I want to just mention my last comment is the more the redundancy or the degree of freedom, it means it takes more time. For example, I think so far we had, I guess we had this when we said our degree of freedom is 1. I guess I'm gonna go up here, and we said we proved that this one on the top right is the degree of freedom is 1 because we have 10 unknowns and then we have 9 equations. And for this one, I said I cannot remember. This one was 3, 2, and 2, so 7 and 6. So it's also 1. Okay, and this one is 3 plus 2. So this one, okay, so here the redundancy is equal to 2, which means solving this one here on the bottom left is more difficult and more mathematically involved than on the right. Why is that? Because simply the redundancy or the degree of freedom. The bigger the number, the bigger the difference between the number of equations and number of unknowns, then it becomes more indeterminate and it becomes more difficult to solve. That's my closing comment, and let's go to the next topic. And the next topic is something called stable versus unstable. Okay. Okay. So here, I'm sorry, like again, says my system, I don't know, doesn't act the way I like. Okay. So our last topic before we switch to SAFI is stable versus unstable structure. So let's first of all, what do you mean by stable? Okay, forget about math and forget about what I'm writing. If I tell you stable, what does it mean? It means it doesn't go anywhere. It doesn't move as a rigid body. Yes, it deforms, yes, but it doesn't move as a rigid body. Okay, so that's called stable. Obviously, from the name unstable, it means if you touch this structure, it's going to move. Okay, now guys, I'm not going to spend time. There are lots of discussion to this one. There is something called external stability and something called internal stability. My focus will be about external stability, which means I have enough restraint for my structure to stay in place. Again, I'm focusing on external stability, not internal. Internal stability is a different topic. So for external stability, it means I'm restraining, I'm providing enough support for my structure not to go anywhere. Now, there are 3 conditions. If you see them, they are not happening, it means your system is stable. And I'm writing them here. So we have here A. So look, please read my document. We have A and B and C. Those, if you find one of them is met or satisfied, it means your system is unstable. If none of them is happening, it means your system is stable. Number one, we do one more time, compare between the number of reactions and the number of equations. Okay, if the number, we said it before, we said it, if they are equal, that is statically determinate. If the number of R, which is the unknown, is more than the equation, which is 3n, it means it's indeterminate. However, if the R is less than the 3n, it means your system is unstable, okay? Because simply there is not enough restraint for your system in place. For example, put a beam on 2 rollers. What happens? If I put a simple beam on 2 rollers, not a hinge and roller, 2 rollers, what happens? It means if you touch the beam horizontally, this beam will just move because simply the number of reactions is 2, the number of unknowns are 2, and because it's a simple piece, we have 3 equations. So we have equations more than the unknowns, system is unstable. Number 2, or B on my list here, if all the reactions are parallel, it means your system is unstable. So all you have to do is look at your structure and put your reactions. If all of them are parallel, it means your system is unstable. Number 3 or number C, if all your reactions are concurrent, it means all of them, they pass through the same point. It means your system is said to be unstable. And remember, in civil engineering, we design structure to stay in place. It doesn't go anywhere else. So that's something we have to make sure and ensure before we do that. Okay. Now I have few examples for you to confirm that you guys got the idea of stable and unstable. Number one, look at the one on the top right. So the one on the top right, okay? So the one on the top right, I have a hinge on point B, and on point A, I have a roller, but the roller is oriented in a way so the reaction will go through point B. Guys, look at this. If we think about ABC, which one is happening right now? Are they
C.
parallel? Can I get some help? We're trying to see whether this structure on the right is stable or unstable. Okay, so I'm going to explain the structure. It is hinged at point B, and then there is a roller at point A, where the roller is oriented in a way so the reaction will go through point B. I'm asking you, can you say it again?
Unstable.
Stable.
Unstable.
It's
Stable.
unstable because simply your three reactions, we have two at point B and we have one at point A, and the three of them, they are coming to the same point, which is point B, so which means they are concurrent, which means it's unstable. Okay, okay? Hello? Okay, next is, how about this one here? So this one here, we have a hinge at point A and we have a roller at point B, but the roller is oriented so the reaction will be horizontal. Is that stable or unstable? This one is stable. Why stable? You have to make sure that none of the ABC is happening. Let's do it one by one. Number one, how many unknowns?
3.
Thank you. How many equations?
3.
3. Thank you. So which means the balance, it means we don't have more equations than the unknowns. So great. So A is not happening. Number two, are my reactions parallel? Are they parallel? All you have to do is just draw two arrows at point A and then draw one arrow at point B, and you can see they are not parallel, which means B is not happening. Number three, are my reactions concurrent? They are meeting at the same point? The answer is no, which means this one is a stable system. Again, let's look at two more. Guys, without any further, you can do that on your own. Obviously, this one is not really unstable, is not. It's completely stable because even this one is indeterminate. Look at this, it's indeterminate because we have three on the left and 3 on the right, so that's 6, and we have 2 from the entry hinge, so we have total of 8 unknowns. We have total of 8 unknowns, okay? 8 unknowns. And we have total of 6 reactions. I'm sorry, 6 equations, because it's 2 pieces, and every piece will give 3 equations. So 2 multiplied by 3, we will get 6 equations. So you can see my unknowns are more than the equations. So it's indeterminate, which means it's statically stable. Okay. How about, guys, look at the bottom left picture. So the bottom left picture, it's a continuous beam on 3 different rollers. 3 rollers. Okay. Guys, please, it's kind of disturbing a little bit. Could you please mute yourself and speak only when I ask you? Make sure that your mic is muted, please. Okay, now, so do it one more time. So now, guys, I'm focusing on the bottom left corner. We have a beam, and this beam is supported on 3 rollers, A, B, C. Okay? The test here is we want to see if this beam is stable or unstable. Let's go one by one. A, let's look at the equations and the unknowns. So, guys, I'm asking you here, how many unknowns?
3.
Thank you. That's correct. Why 3? Because for every roller we have one unknown, so which is going to the y direction. So we have 3. Let me ask you, how many pieces this beam is?
1.
Thank you. That's true. It's 1. That's 1.
Yeah, 1.
So 1 times 3 for every piece. So we have 3 equations. So which means A is happening already. Sorry, it's not happening A, because we have a balance. Like we have 3 unknowns and 3 equations, which means A is not happening. So far, what we can say until now, stable. Number 2, are all the reactions parallel?
Yes.
Yes, which means don't do anything else. Stop and say, okay, this is unstable. This is unstable. Great. Let's do the last one. The last one. So the last one is we have to go again through three different checks. So let's go ahead and check it. So for the number of the unknowns, I guess we have 2 on point D, and then we have 1 at point A. So we have total of 3, and then we have 2 intermediate hinges, which means we have total of 7 unknowns. 7. 2 at point D, 1 at point A, and then we have 2 hinges at point B and C, which will give us 4 equations, 2 at point B and 2 at point C. So how many unknowns in this system? 7. However, how many equations do we have? So let me ask you, how many pieces?
3.
How many pieces?
3.
3 times 3. So we have
9.
a total of 9 equations. Okay, guys, look at this. We have 9 equations, and we have only 7 unknowns. Guys, this means your system is unstable, okay? Because we have more equations than the unknowns. So done, we don't have to do anything else, it's unstable, okay? Guys, look at this, you have this document, please review. We have even the solution is here. If you are interested, you will find the solution is here. Okay, dokie. Let me see, do we have any questions so far? Do you have any questions so far? Okay, great. So thank you so much. I'm going right now to show you like we have more training today for SAFI. So let me check for sure. Maybe somebody needs my help. Okay, not very important. Okay, guys, look at this, please. So there is I'm gonna give you like more than 2 hours on SAFI training, which for sure is gonna happen today, and is gonna also continue early next week on Monday. Now, I went last week and I improved significantly my tutorial on SAFI from last few years. So now we have a way better tutorial on SAFI. Let me show you first where to find this, just to make sure that everyone is following and is able to get the document. So on your my site, you just have to log in and then go to D2L and go to my course, which is the concrete design. It's over there. You go to content, then I think it's under SAFI demo. So you can see here there is a folder. There is a folder called SAFI demo, and if you go under SAFI demo, you can see what I did is I uploaded the PDF file that takes you through a step-by-step, very detailed, from my perspective for sure. Okay, so very detailed tutorial on SAFI. Together, I also uploaded a couple of examples. So basically, this is the frame I'm analyzing in this demo. Okay. Anyway, so guys, I'm gonna show you the document. Here's my document. And my document, as I said, it gives you a little bit of introduction, and it takes you through a very detailed step-by-step to solve the structure in this picture. Okay. So you can see here, I have a structure. Probably you've seen this one last year. It's kind of frame, but not really a single bay. It is double bay. I have created for you guys to see this in 3D. I have created here kind of a Revit model. So this is my Revit model here for my building. The building consists of several frames. So this is one frame, another frame, repeated frames. As I said, I think a couple of classes ago, that you can see the structure is a 3D. So what you see here is a 3D structure. However, when we do the analysis, you can see it's 3D. Huh? When we do the analysis, we typically simplify or abstract our structure into 2-dimensional element. So you can see in my document here, I kind of turn my 3D structure into 2-dimensional repeated frames. Some information before we start. So there are some dimension, and I can say here, all dimensions are in millimeters. So the 10,000, it means 10 meters and 8 meters, and the height of the frame is 5,000. The concrete strength, which I will tell you why do we need the concrete strength, is 30 MPa. All the beam column connections are rigid. It means the connection between your column and your beam is rigid. It means it's not like a hinge. It doesn't allow rotation. If your beam wants to rotate, it will grab the column together with it. And then all the supports are hinged. So we have a support here at this point. So I have a support here at this point. I'm gonna point out, and I also have a support here at this point, another support here at this point, and all of them, they are hinged support. Next is we have some loads going onto your system. Ioniform load applied on the roof. So roof dead load is equal to 15 kilo Newton per meter applied on the roof beams. The live load is 6 applied on the roof beams. We have some wind load coming from the left, so blowing here, blowing from going to the left, and also we have some live load blowing to the right. Okay. And something I'm gonna give you more details. We have to make a structural analysis, and we have to follow Alberta Building Code 2019 load combination. I think I touched on this one. I think the last class, and I said loads do not interact with your structure individually, except the dead load. Sometimes, yes, it's only dead load, but in general, dead load acts with the live load, with the snow load, and sometimes wind load. And that's why there is a concept called load combination or load combo. And the load combo, those are completely defined by the codes, whether the National Building Code or Alberta Building Code. Okay, so now let's see how can we use a software to find all the reactions, all the bending moment, all the shear force, all the deflections according or under those specified loads. Okay, now listen to me, please. You have to just watch me. I'm not going to ask you to do anything right now. Just enjoy, entertain watching me while I'm doing the business. Later on, what you have to do is you will have to follow the steps in this document here. So if I go down, you will see I give you every individual step. Okay, so what you have to do next is you follow those steps in my 24 pages tutorial. Why it's 24? Don't say, okay, you know what, that's too much. Tahir is giving us too much. It's 24 because I made it so detailed. It means I have every snapshot of every individual step. Okay, and that's why if I just kind of ignore one and I say, okay, that's easy, probably you guys maybe you missed that. So please don't think of the 24 pages. It's going to take me hours and hours and hours to finish it. Not really. There's just more details, and you can see if I go through my tutorial, lots of snapshots. Lots of snapshots tells you step, where to click, what to do, what to enter in your tutorial. Okay, now I'm going to minimize this one for now. And guys, as I said, please, for now, just entertain watching me doing it. Okay. Okay. Sorry for that. There looks like the signal is not is not great. Okay, guys, look at this, please. I'm gonna stop the sharing, and then I'm going to start the sharing one more time, and then I'm gonna share with you guys my desktop. Guys, look at this, please. Look at my desktop. I'm not sure if I have SAFI here as an icon on my desktop. However, it's as simple as you go to your search, and then type in SAFI. It means we're trying to run the SAFI, and it comes from GSA, so it's just run the software. Okay. Now I want to mention something that before you start the software, you must have the global protect. You can see on my bottom right here, there is a global protect, which is a VPN client. It means as if you are inside. Otherwise, there is no way for you to run the software. So please make sure that you run the VPN client on the background. Okay. You know what? This is not what's going to happen to you. And I know somebody of you guys connected with me and ask me, SAFI me is giving me an error, and which is okay, by the way. When you run the SAFI for the first time, you sometimes get some error. Okay. So again, please follow my tutorial. You will see it's very simple. Make sure your VPN is running, and then follow, say next, next, next. Is going to give you an error, and the computer software will crash. You have to do this probably twice or 3 times until your software is up and running. Okay, dokie. It's here, by the way, so don't worry if you don't even get it. If you go back to my tutorial, you can see I pointed out this here. You can see this is what you will get. Okay, if I zoom in, this is what you will get. You will get this kind of license manager. And as I said, all you have to do is you simply have to click here on the next, and then follow next, next, next. Is going to give you an error, and the software will completely crash. And then you do it 2 times, and then the third time will be, you will have exactly what I have here on my screen. Okay, dokie. Now we're ready. Here is my software. Okay, and first thing you will see is that it comes to kind of a brand new empty project. So what you see here is brand new empty project that has so many grid lines. So what you see here, those dotted line, and they are going from 1 to 26, and from A to Z, those are 26 by 26 grid line. And the distance, I don't know what is the distance between grid lines, and I don't care, because simply I don't need all those grid line. I'm going to change and edit the grid line to match my requirement. I don't need 26 by 26. This is too much, and I don't know even if the distance is good or bad. Let's go back to my document, and let's agree on how many do I need, how many grid line. Remember, really, the number of grid line, you have to look back at your structure, okay? So when you look at my structure here, probably some of you will figure out how many grid line in X and how many grid lines in Y do I need. Any help for a mark? Because you guys seem to be sleepy now. My question is, how many grid lines in the X direction? And I have to be specific. X is here. Okay, so this is my X direction. So this is my X direction. Who said that, Hamid?
No, that was me.
Gord?
Yeah.
Okay, that's true. So mark for Gord. So yes, you do have
how
3.
many?
1. So along the X, I need 1, which is X A and B and then C. Okay.
4 in the
how
Y.
many? Excuse
4
me.
in the Y. 4 in the Y axis.
Okay. Can you please, Hamid, tell me where are the 4 axes? Like I'm gonna tell you, here is 1 at the main floor, and
2.
here is 1 at the second floor. Where is number 3? Where is number 4?
Oh, sorry, I was looking at it backwards.
Okay, so guys, now we need 3 in the x-axis, and we need only 2 along the y-axis, and that's what I'm going to do in a second. Watch this, please. So in order for you to access the grid and edit them, it's as simple as, and again, please don't try to memorize. Do not try to memorize, because simply it's on the tutorial. We go from menu edits, and we go to grids, or after some time, if you are professional, you can use the short keys or the hotkeys like Control plus G, and so this will open up the dialog where you can edit your grid lines. There are so many ways. I'm going to show you one of them. I'm going to go to, you can see here, there is lines along x-axis or axis X, and then lines along y axis. So I'll do it one at a time. So I'll go to the X and edit them. You can see those are the 26 axes. Look at this, please. It looks like Excel, which means I can mark those. I need only 3. Okay, so I can go ahead and I can go ahead and I can simply mark them. So mark whatever you don't like and you want to get rid of, and then take a right click and say delete. Are you following? So you mark whatever you don't like, and then you say delete on the right click. It's going to confirm, yes, I'm sure. Go ahead. You can see just like Excel, I have erased all the grid line and I left 3 of them. Guys, look at this. So now you can see on this Excel file, same like Excel file, you can see there are some distances between the grid lines. Relative and absolute. Relative, it means between one grid line and the previous one, and absolute, it means it's from the origin. Okay, so let me switch back to my PDF file and I look at this, please. So I have here 1, 2, 3. In terms of relative, look at this. The number here is 10,000 millimeter, and the number here is 8,000 millimeter. Guys, all you have to do is you take this number. So this will be the distance between your grid line number 1 and number 2, and then you do it one more time here. Watch me, please. So what I have to do is I need to double click here, and you can see right now it's 1,000. I'm going to edit this one to 10,000. And remember, what are the units? It's here, relative, and it's in millimeter. The next one is I double click here, and then I write here 8,000. What does it mean? You're telling the software between A and B, make it 10,000. Between B and C, relative, make it 8,000. And by the way, we are done. It means all you have to do, come back here and hit OK. And look, guys, I'm going to do something, and then I'm going to come back to the same place again. If I hit OK right now, see what happens? And instead of having 26 X grid lines, now I have only 3, A, B, and C. A, B, and C. Between A and B, it's 10,000. Between B and C, it's 8,000. But still, I have so many of Y grid line. What to do? Guys are smart, huh? You go back to edit, go to grids, and then this time this part is done. I go to edit lines. You can see so many. I mark, remember Hamid, we need only 2, huh? Only 2. So I mark everything else, and I come back and I say delete, and I confirm that. So now we have how many? We have total of 2. Okay, one at the main floor and the other one at the second floor. Now you can see if I go back to my document, what should I put here? Can you read from this drawing here? What should be the distance between the main and the second floor?
5,000.
Thank you so much. That's correct. Who said that?
Mehdi.
Mahdi, you get 1 mark. Just give me a second here, please. Okay. So yeah, you can see here the main level or elevation is 0, and the second floor is 5,000. And that's where I come here. I go to this number here, and I type in here 5,000. Okay. And then accepted and hit OK. Another OK. Congratulations. Please watch this. Now, the thing that is really annoys me with this software, if you try to use the mouse the same, use it in AutoCAD, it just changes the rotation of your view. So please, so if you want to band things up, that's what you have to do. You click on the handle on the left side here. You click on the handle, and simply you translate, and you scroll your mouse. Then you can see I'm zooming in. Okay, you can see we are on the way, huh? We have already established our grid lines, and we have established like the X and Y. So all we have to do, I guess, next is use those grid lines to draw our structure. Okay, would you agree? Now we do it this way. If you look at the toolbar, the toolbar here on the bottom, on the top left, and again, you don't have to memorize, because those toolbar, I guess, just like any other software, they have something called tooltip, which means if I go here and I leave my cursor for a second above the icon, so you can read, it says here add. If I leave it for a second, it will say add joint, or you can use the hotkeys Shift plus J. And what this does is simply allows you to add joints. So I'm going to go ahead and add joint here, another joint here, one here, one there, one there, another one there. You can see I have added total of 6 different joints. Next is I'm going to connect these joints by members. How? You go back almost to the same toolbar, and if you leave it for a second, it will say add a member. And you can do that also using the hotkeys, which is Shift plus. Let's see that. Shift plus M.
Sorry, Tahir. Siham was saying that you got your dimensions backwards between A and B and C.
That's not true. I got the naming backwards, but the dimension is correct. Okay. So if I go back, yes, my A. So all I've done is I just put the A is on this side, and B still the same, and C went on this side, but it still is 10 and then 8. Okay. And by the way, so you guys know, A, B, C, those are the Revit grid lines, and the A, B, C here, those are the SAFI grid lines. So it's not backwards. Still, this is supposed to read C, and this will stay as B, and the A is here. So this will be 10 meter, or it is 10 meter, and this one is 8 meters. Okay. So we go ahead and we simply go ahead and draw our members. So I click here on Shift M or create member. And guys, what you need to do is you can see my cursor has changed. Looks like I'm ready right now to start connecting the joints and come up with the members. Watch me please, just like AutoCAD. You click here and then you go click here. It means I've done my first column. Now I go here, I go there, second column. I go here, I go there, third column. Now I'm missing the beams. So I go here and I click here and click there. So this is another one. And then from here to there, last one. Now, guys, I have 2 very, very important notes here. Very important. Number 1, if you're able to match all, like the way that you draw all the columns, like for example, from the bottom up, all of them, they will go from bottom up. This will make your life a little bit easier in the future. Okay. So make sure if you can. It's not a must. It's not a must. However, it's good advice for you if you go from bottom up or up bottom, but be consistent. If you draw all your column up down, like from grid line 2 to grid line 1, great. Or you can do it from grid line 1 to grid line 2. So that's number 1, which is optional, but it's important as an order, or it will make your life easier in the future. However, the next one is not an option. Is not an option. Please watch. What if I come up? I'm gonna, select, and I'm gonna select this guy here. I will select this guy. So this guy, I'm gonna select it, and then I will delete. And then I will do the same thing. I'm gonna select this guy, and then I'm gonna hit delete on the keyboard. Guys, let me ask you: when I start drawing the top beam, what if I go from here and then straight to here? Is that good or bad?
It's bad. It's a one beam.
That's, by the way, did you say bad or good?
Bad.
Who said that? I think Jelly and also and who?
Mehdi.
Mahdi. Okay. So that's half of the question. Okay. So it is not good, really. It's not good. But the question is why? Why I cannot just go from here to here straight? Okay. What's the problem?
Because the software will rate it as a one member.
It's not really what happens. Any other input?
Like it's not going to connect to the joint at joint B.
Who said that?
Dominic.
Dominic. Okay, I will give you. Is that Domenico?
Yeah.
Okay, I'm gonna give you for this one because really, it's good. I'm gonna give you three marks, and I will give both to Mahdi, and then Jelly. I'm gonna give them another mark. Okay, so Jelly 1 mark. Guys, that's true. If you ignore and connect straight from this point here to this point here, what happens is as if the column and the beam is not connected, so the beam will span all the way from this to this right away. And you will see this in the analysis. Your beam will deflect all the way and span from grid line A to grid line C. It's a must. It's a must that you make a beam to this point, and then another beam from this point to this point. Not a choice, otherwise your model is wrong. Okay, next is, so now we can see is things start to see how you're modeling your structure into SAFI. You're copying your structure from the paper or from the PDF to your SAFI. Guys, the next step is to assign the support. Assign the support to your structure, okay? So now you can see I have one, what I'm pointing out right now, I have one support here, one support, one support. The way we do it is we need to first select the joints. And the way we select the joint, we click on the keyboard letter S one more time to assign those joints some restraint or some support. You initially have to pick them or select them. How we do it is we type in S, and please watch my cursor as I type in on my keyboard. Please watch this. I'm going to type in S. You can see the cursor shape has changed, and now I can draw, just like AutoCAD, I can draw a box around the three joints, and the three joints right now, they are in blue. It means they are being selected right now. Next is you right click after selection, and you go to joint attributes. On the right click menu, you click on joint attributes. When you click on joint attributes, you can see this is where you assign a support, and probably those are kind of complicated for our course, like springs, which means it's elastic support, or displacement. So those are kind of advanced support, but here is really what you want to do. If you want to go very simple, you can simply click on bend, which is simply bend. It means it's hinged, okay? And guys, as I click on bend, please, what's happening here on this side? Please watch this. So I'm going to click here on bend and watch the left side. You can see the software knows that bend, it means we are restraining the X and Y motion. Now, I want you guys to look at the bottom left corner where it shows you the axes of your coordinate system. The blue is the X, so this direction is the X, and this direction is the Y, and perpendicular to your screen in red is your Z. And you can see here, bend means restrain movement in X and Y. How about if I go and do fixed? Guess what? See what happens? The software is smart and simply checks off all those X and Y, and also rotation around Z. Anyway, it's not fixed, it is bend. And for your information, something, by the way, this discussion is kind of outside the SAFI, but we try, if we can, avoid to make any fixed support. It is if we can. If there is no other option, we do it. But if we can avoid fixed support, we do it. We only use bend or hinged support. The reason is it causes moment, and if it causes moment, it will cause uneven stress on the soil, and you are in trouble. So that's why you have to be very careful. We always do it hinge if we can. So anyway, it's bend, it's hinge. And by the way, if you want to do it manually, like for example, uncheck those, let's say uncheck those, and if you wish, you can come here without hitting those on the right. While they are so easy, you come back here and say, make it X, make it Y, stop them from movement, and good to go. Are you following? Am I going very fast?
No, this is
Sir,
good.
I have only one question.
Sure, go ahead.
In this software, how come it doesn't emphasize the ruler? How come it's only bend and fix?
Again, I'm not the designer, but you can do it roller here. So if I want to make it roller, I'm gonna restrain my my Y, and I'm gonna move it in the X direction. So you can get the roller from this side. I know it's not kind of pre setup again, but I'm not the designer, so I don't know why this was choice. I don't know. But you look at this right now. If I hit OK right now, it means all of them will be roller. Because read it, please. It says movement restrained in the Y. Only the Y. But X and rotation, it's allowed. Okay?
Okay.
So anyway, I'll go back to here. I'm going to say X and Y. I'm going to hit OK. And look at what happens, please. Look at the graphics. I want you to look at the graphics, and simply right now what happened is you get something extra. It tells you from the graphics that those 3 points are restrained in the X and Y. It means they are hinged or bent. Okay, guys, are you following? Okay, guys, look at this. I think it's time for me to break because of my voice. I need some break, and I will come back here at 12:15.